Students, now we are going to continue with the applications of linear simple harmonic motion. In practical, in real life, we are having some application based on linear simple harmonic motion, like a spring tied to the body performing linear simple harmonic motion, as we have seen earlier. In the case of spring tied to an object, we are having a practical based on simple pendulum. So here we are going to discuss about simple pendulum. What exactly is simple pendulum? Already we are knowing about it. If we take, ideally if we are going to take a pendulum, we are having a string tied to a heavy mass and this inextensible string. आपका जो string होना चाहिए inextensible होना चाहिए when it is going to perform oscillatory motion. So string जो है inextensible होना चाहिए, light होना चाहिए और and it is tied to an heavy mass which is performing linear simple harmonic motion. But practically if we are going to see, instead of heavy mass, we will take it as a metallic sphere. We can take a small metallic sphere, that is a bob. It is called as a bob, which is going to perform linear simple harmonic motion. So let us go for practical simple pendulum. Or the question here arises is simple pendulum. Motion of a simple pendulum is also linear simple harmonic motion. So what basically about simple pendulum we are seeing? In simple pendulum topic, we are knowing what is simple pendulum. We are just deriving here that motion of a pendulum, motion of simple pendulum performs linear simple harmonic motion, or derive expression for time period. Expression for time period of सिंपल पेंडुलम. फॉर्मूला यहाँ पे क्या फॉर्मूला है पेंडुलम का, अभी हम लोग डिराइव करेंगे इससे. एंड इज एन एप्लीकेशन ऑफ लीनियर सिंपल हार्मोनिक मोशन, एक एप्लीकेशन. सो एक्सप्रेशन फॉर टाइम पीरियड फॉर सिंपल पेंडुलम. ओके, इन द टॉपिक वी आर हैविंग सिंपल पेंडुलम. Let us see. We are having a rigid support, a light string, massless string. Instead of light, we are having a massless string. One end of the string is attached to the rigid support, other end of the string is attached to a metallic sphere, that is a very small sphere, that is called as a bob. The bob is having, the metallic bob is having radius r. Having radius r, and the small l is the length of the string. And if you see, total length of the string is right from the rigid support to the center of gravity of the bob. Center of gravity of the bob. Center of the bob से लेके rigid support का total length of the string है. ये आपका हो गया pendulum. A small metallic sphere which is attached to the string and it is attached to the rigid support we are having. So L small r, L plus R, that is total length is L plus R. We are finding the derivation of time period of simple pendulum. Suppose in a given time t, we are giving a small angular displacement, or if the bob is displaced from its mean position, at point O to suppose at point P, and it is displaced from its mean position making an angle theta, the bob is going to perform linear simple harmonic motion, because at this point, due to the gravitational force or your restoring force become maximum, it will try to come back to its mean position. So how it will bring back to the mean position, we will see that, how it is coming to the mean position, and what is going to happen when it comes to the mean position. It is not going to, due to inertia, it is going to move more further, and hence it is going to perform between two extreme positions, it is going to perform linear simple harmonic motion. Here we are having L is the total length of the pendulum, theta is the angular displacement, and here if the particle is moving from this point to this point, we can assume it has x, displacement from its mean position is x. Now when a bob is displaced from its mean position to a point P, at point P, force acting on the string is given by T. We write it as T dash. Why we write T dash? Because we can write T also, but we are adding T dash because time period will be given by T. So we write it as T dash. So T dash. T is a tension in the string which is acted along the string at point P. So how many forces are acting at point P? We are having two forces. So at point P, two forces are acting. Two forces are acting. Number one, T dash, tension along string, and number two, the weight of the bob, that is mg, weight of bob in vertically downward direction. Vertically downwards direction. So something is balancing. So here weight mg which is there is in the vertically downward direction, that is mg. Something is balancing T dash. So what is balancing T dash? So here now T dash is balanced by what? Resolving mg into two components. Resolving. So we will resolve mg into components. Mg sin theta and mg cos theta. How? Here we are taking mg is in downward direction, we are taking components of mg. This tension is string, we are taking components. This angle is theta here. This angle is theta. So mg is resolved into two components. The adjacent side we are writing it as mg cos theta, and perpendicular here we are writing it as this one is mg sin theta. Perpendicular components. Theta. This angle and this angle are equal. Why? Because we are having two parallel lines. We are having two parallel lines, and here this angle theta and this angle theta. If you are going to see this angle theta and this angle theta, nothing is corresponding angles. So here adjacent it is mg cos theta and here we are getting mg sin theta. It means tension in the string is balanced by your weight ka mg cos theta and the unbalanced force which is remaining here, that is mg sin theta. So this unbalanced force which is acting at point P, unbalanced force, ये आपका bob को back to the mean position लेके आएगा. So mg sin theta is going to bring the body bob back to the mean position. Here theta will be 0, mg will be maximum, it is in down, but due to inertia it is going to move forward. Again at this point, again the force is acting here. Okay, so mg sin theta will become maximum here. So at this 2 point, mg sin theta is going to become maximum. Okay, mg cos theta will become, cos 0 is 1, it is going to become mg. So weight mg will be in downward direction. So which will balance tension in the string. So your tension T dash in the string is balanced by mg cos theta at this point, and mg sin theta is unbalanced force which is bringing the body bob back to the mean position. So mg is resolved into two components. Hence we are getting the equation therefore mg sin theta is the unbalanced force, therefore force acting at point P, therefore F is unbalanced force minus mg sin theta. Now why minus sign is there? Negative sign indicates that force and displacement are opposite direction, angle. So when the body is going this side, the force acting is in this side, mg sin theta. So force equal to minus mg sin theta. Here F upon m, here it is minus, if we take now, but for very small angle, we take sin theta is approximately equal to theta, and here we will get F equal to minus mg into theta. F by m minus g theta we can write, and F equal to ma, so therefore we can write A equal to minus g theta, or you can change further, you can write later also, we can go with acceleration later on. But what is theta? Theta from diagram, theta is what? It is this displacement x by L, that is opposite upon adjacent we can take. So theta is x, that is this is x, it is from mean position, this is x, I can take x by L, L is my adjacent side or length of the string. Tan theta and sin theta is approximately same. So sin theta is opposite upon hypotenuse and tan theta is opposite upon adjacent. So we can take tan theta or sin theta same because for a very small angle. So theta is x by L. Therefore what acceleration we are getting is A equal to, we get minus g theta, angular displacement. This angular displacement is depending upon x upon L. This is my suppose. I'm just putting this is equation number 1. It means it is telling you that acceleration is proportional to displacement. Okay. Or we can also tell m multiply force is proportional to x. Means it is giving you the definition of linear simple harmonic motion. A proportional to x. Negative sign indicates that here where g and L are constant. We know L and G are constants. G is nature, acceleration to gravity 9.8 or L मेरे length of the string मैंने constant रख दिया. So A proportional to x where G and L are constant. Negative sign indicates that acceleration and displacement are opposite in direction. So acceleration का मतलब force is directed towards the center, acceleration is directed towards the center. So we got from here we conclude that motion of pendulum performs linear simple harmonic motion. So motion of a pendulum is performing linear simple harmonic motion. Now expression for the time period. For time period let us go more further. What is my time period given by? Time period is 2 pi upon omega. And what is acceleration in terms of omega? A equal to omega square x. ये तो पता ही था मुझे. So omega क्या हो गया? What is omega? Under root of a by x. acceleration upon x. This is acceleration. This is acceleration. I think you can write c ac. अपने ac से denote किया है chapter में ac acceleration. So therefore time period is t is equal to 2 pi upon omega. What is omega? Upon omega is x upon a. And using one, here what is x upon a? X upon a is L by G. Neglecting minus sign, we'll get time period t is equal to, using one, 2 pi under root of x upon a. Here we are getting x upon a is L by G. So now you can prove it. We are having formula for time period. Time period is given by under root of L upon G. So time period of a simple pendulum here. Therefore time period of simple pendulum is given by 2 pi root of L upon G. Means time period of the pendulum, जो time period है जो pendulum का, that is frequency 1 upon t, that is 1 upon 2 pi under root of G by L of frequency. So time period of pendulum of frequency. So time period is given by 2 pi root of L upon G, depends upon length of the pendulum and acceleration to gravity. मतलब जो उसका time period है, one complete oscillation के लिए कितना जो time लगता है, यहाँ गया फिर वापस इधर आया, एक complete time period के लिए it is depending upon उसका length पे depend करता है और acceleration. Already we have seen before also. मैं आपको बता था, अगर मेरा लेंथ 25 सेंटीमीटर रख देता हूँ, 25 सेंटीमीटर अगर मैंने रख दिया लेंथ, धागे का लेंथ, और मैंने छोटा सा एक रबर लिया, घर पे एक्सपेरिमेंट कर सकते हैं, बॉब ले लिया और मैं लेंथ 25 सेंटीमीटर रख देता हूँ और एक्सेलरेशन नेचर एंड पर जस्ट रिलीज इट. रिलीज होते थे आपको क्या मिलेगा? इट इज परफॉर्मिंग लीनियर सिंपल हार्मोनिक. मतलब 1 सेकंड में आएगा, 1 सेकंड, 1 सेकंड, 1 सेकंड, 1 सेकंड. You will get this formula. Time to t is 2 pi root. So put the value length 25 सेंटीमीटर, G 980 सेंटीमीटर पर सेकंड स्क्वायर इंटू 2 पाई करोगे एंड कैलकुलेटर मारोगे तो टाइम पीरियड इज 1 सेकंड आपको मिलेगा. एंड हेंस वी कैन आल्सो टेल दैट टाइम पीरियड डिपेंड्स अपॉन स्क्वायर रूट ऑफ लेंथ ऑफ द पेंडुलम. इट इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर रूट ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी. इट इज इंडिपेंडेंट ऑफ द मास. इसका मतलब जो भी मास रहेगा उसका इंडिपेंडेंट, बड़ा ऑब्जेक्ट लो या छोटा ऑब्जेक्ट लो वो इंडिपेंडेंट रहेगा. एंड इट इज इंडिपेंडेंट ऑफ द एम्पलीट्यूड आल्सो. and energy is proportional to amplitude square. मतलब amplitude क्या आएगा वो अब इधर लो या इधर लो, it is in, but you have to give a very small amplitude for the condition of time period of simple pendulum. आपको थोड़ा सा amplitude देना है, फिर वो it will start oscillating on its own. So amplitude should be very very small. So these are some conditions of time period of simple pendulum, and formula is t is 2 pi root of L upon G. Students, now we are doing seconds pendulum. A short topic we are having here. Seconds pendulum. Now what is the meaning of seconds pendulum? Simple pendulum ही है, लेकिन इसको हमने seconds pendulum बोला है. कब seconds pendulum बोला है? It is a pendulum whose time period is 2 seconds. जिसका time period 2 second है. मतलब suppose pendulum यहाँ से start हो गया, 2 second, 1 second and again 1 second. So 2 second लगता है उसको एक complete oscillation के लिए. You have to complete one set of movements. So basically it is a pendulum whose time period is 2 seconds. So what is seconds pendulum? It is a pendulum whose time period is 2 seconds. Reference के लिए काम आता है. अब time period 2 seconds चाहिए. So my formula for pendulum क्या है? 2 pi under root of L upon G. आपको लेंथ कितना रखना पड़ेगा? So here when t is 2, when time period is 2 seconds, what is my length? So 2 is 2 pi under root of L by G, squaring both the side. Squaring both the side 1 square is 1, pi square L upon G, so L is equal to G by pi square. This is my formula. G up 90 रख दो, pi 3.14 square. If you will put the values of this, you will really get, I think so, 1 meter. 100 सेंटीमीटर आपको मिलेगा या 1 मीटर मिलेगा. L is G upon pi square. G 9.8 रखोगे तो 1 मीटर मिलेगा, 980 रखोगे तो 100 सेंटीमीटर मिलेगा. So what is seconds pendulum? It is a pendulum whose time period is 2 seconds. We are having a relation of L is G upon pi square. So with the help of L is G upon pi square, we can determine acceleration due to gravity G if we are knowing length L, length of a pendulum. So with the help of seconds pendulum, we can determine acceleration due to gravity at that place.